Okay, this is the 4.4 notes video, and I apologize this is a little late. But the learning objective is I can solve an equation for any variable in a literal equation. So 4.4 is all about being able to justify what we are doing. So I put out over here all of these steps and I specified what's going on. So the big thing that we need to know is that solving literal equations is similar to solving linear equations. In both cases, we need to undo what has been done to the variable. We do that by doing an order of operations backwards. In other words, we use the inverse operation. So what that's telling us is that if it's being done to it, we need to undo it. So most of these are a repeat of stuff you learned in 4.1. So you guys learned the distributive property, the addition property, the subtraction property, the multiplication property, and the division property of equality. So in 4.4, we're going to bring all of those back. And then we're also going to add that there are a couple other properties that also exist. So on this one, we have the additive identity. Okay. So what the additive identity says is that if you add 0 to any number, it does not change the number. Okay. And the multiplicative identity is really similar. What number can you multiply by and not change the number that you started with? Well, that's 1, right? You can multiply by 1 and you're not going to change what you started with. Okay, so those are what we call the identity properties of addition and multiplication. So that's useful to know when we're solving equations because we can cancel some things out because of that. So that's kind of what the properties look like. So I'm going to walk through this example with you and show you what all of these are. And as we get to some of these others, I'm going to go ahead and fill those in. But not all of these examples are in, not all of these properties are in this example. So there may be some that we have to go back and fill in a little bit. So let's go ahead and get started. So if we start with 3x over 2 divided by 5 equals 7, the first thing we're going to do, remember fractions are grouping symbols. So we have to deal with what's on the bottom of that grouping symbol before we can do anything else. So the first thing we're going to do is multiply by 5. Okay, so we're going to multiply both sides by 5. Okay, the reason we can do that is the multiplication property of equality. That was from 4.1. Remember, it says that as long as you do it to both sides, you're going to stay equal. So if you want to multiply by 5 over here, that's fine. You also have to do it here in order to keep it equal. Okay, so then we jump down here and we have 3x plus 2 divided by 5 times by 5 equals 7 times 5. So all that we've done is take these 5s that I added and put them down here. Okay. All right, so then we're going to rewrite it. We're going to rewrite it with the associative property of multiplication. So let's make sure we know what that is. Okay. The associative property of multiplication looks like this. A times BC is equal to AB times C. So this is essentially saying that you can multiply A and B first or B and C first, and either way, as long as you're multiplying A, B, and C all together, you're going to get the same answer. You could technically also do A times C and then times it by B. Those would also be equal, okay? So you can flip around where the parentheses are, where the multiplication is happening. So the reason that this is important is dividing by 5 is the same thing as multiplying by 1/5. We've talked about that a lot in class. Dividing by 5 is the same as multiplying by 1/5. Okay, so we're going to go ahead and rewrite this. So the top of the fraction stays how it was, but then we have this 1/5 times 5 and 7 times 5. So the reason that we do that in this case when we're trying to justify what we're doing, so if you were doing this problem, you could just cancel these out and say, okay, I got rid of it, I'm done. But because I want to teach you these properties, I'm going to teach you the long way to do this. Okay, so you would have 1/5 times 5 equals 7 times 5. Now, we did that by doing the associative property of multiplication. Now that we have 1/5 times 5, we're going to use the multiplicative inverse property of multiplication. So we're going to go in here and fill in what the multiplicative inverse is so that you guys know how to use that. So the multiplicative inverse says a over b times b over a equals 1. So what this is saying is if you take any fraction and multiply by the reciprocal, or the flipped upside down version of it, you're going to get 1. The reason that happens is because in fractions, we would multiply straight across, and we would end up with a times b over a times b. And that's going to be something divided by itself, which definitely equals 1. So that's why it works. Okay, so let's talk about it in a more concrete example. So let's take 5/7. So we're saying if you flip that upside down and times by 7 over 5, it's going to equal 1. Why would it equal 1? Well, we would do 5 times 7 is 35. 7 times 5 is also 35, which equals 1. Another way you can think about this is that if you are going to, let's see here, if you're going to multiply by 7 and divide by 7, what's going to happen? Well, they're going to cancel out because that's just 1. So you'd end up with 1 times 5 over 5. Same thing. You could also do it the other way. You could say, well, we're multiplying by 5 and dividing by 5. So that's going to be 1, and you're going to be left with 7 over 7, which is also 1. 1 times 1 is 1. Okay, so hopefully that makes sense why some of these properties work. Okay, so because of the multiplicative inverse, we know that 1/5 times 5 is going to equal 1. Okay, now because of the multiplicative identity that we just talked about, we know that multiplying by 1 doesn't do anything. So we can get rid of that times 1. It doesn't do anything. And we end up with 3x plus 2 equals 35. Now, if you were solving this equation, the steps that I would expect to see, I would expect to see you multiplying 5. I would expect to see you cancel out. And I would expect to see this step. Okay, these two in here are me showing you the technicality behind it, the why behind it, but I don't expect you to write it when you're solving equations. Okay, so the next thing we would do would be to minus 2. And we do that with the subtraction property of equality. That's another one from 4.1. Okay, that just says that if we minus 2 here, that's fine. We just also have to minus 2 here. Okay, so then I just rewrote it out as 2 minus 2 and 35 minus 2. Now 2 minus 2, of course, is 0. Okay, and we know that with the additive inverse property, that is true. So let's talk about the additive inverse. So the additive inverse says that a plus a negative a is 0. Okay, so what that's saying is it doesn't matter what number you take. You could take a, I don't know, let's do like 1,000. If you take a negative 1,000 and a positive 1,000 and put them together, you are always going to get 0. It does not matter which number you do. Anything that you take the negative and the positive and put them together, you're going to get 0. Okay, and that's true here too, right? 2 minus 2 is 0. Okay, so then I just went ahead and rewrote that. Okay, 2 minus 2 is 0. And then we know by the additive identity that adding 0 doesn't do anything. So when we add 0, we can actually just get rid of that. Okay. Now we have 3x equals 33. And of course, the next step we would do would be to divide by 3. It's shown right there. Okay, and that's the division property of equality. And that's saying you could divide by 3 here. You just also have to do it there. Okay. Now we're going to use the associative property of multiplication again. So this is 3x over 3. But that is also the same as 3 times x times by 1/3. Okay. And then we're going to rewrite it with the 3 and the 1/3 together so it's easier to see. Okay. You could also think about it if you need this step kind of in the middle to see this. It is 3 times x divided by 3. That's true. Okay. And then you can actually pull this one out front, I think is the easiest place to see it. So 1/3 times 3 times x. Okay. 3 times 1/3 by the multiplicative inverse that we've already talked about. That's the same as 1/3 times 3 over 1. Here's your matching. Here's your matching. That's going to equal 1 every time. So it equals 1. And then when we do x times 1, we know by the multiplicative identity that times by 1 doesn't do anything, so we can just get rid of it, and we end up with x equals 11. Okay, there are a couple more properties in here that we didn't really talk about, but they are important, so let's make sure we have talked about those. So let's start with the associative of addition because we already did it with multiplication. So what the associative property says is that you can have a plus parenthesis b plus c, and that's going to be the same thing as parenthesis a plus b plus c. So this is saying that the order doesn't matter. Okay, you can do 2 plus 3, you're going to get 5. You can do 3 plus 2, and you're still going to get 5. Which order you do the 2 and the 3 in doesn't matter. Okay, and that's true here too. So you'll notice that this is all addition and this is all multiplication, and that's why we keep them separate. Okay, those kind of go with the distributive property. One of my students asked in class, well, what if it's multiplication and addition? Well, that's what we call the distributive property, because that would look like this. Multiplication here, but addition here. Okay? So when that happens, when they are mixed, when they're not separate, we use distribution to put it in. And we know that we would do A times B plus A times C. And I think you guys are pretty comfortable with that. But really, the distributive property is the associative property of addition and multiplication combined into one. Okay. All right, the last one is commutative, and it also has to do with order. A plus B equals B plus A. You can flip around an equation and it's going to be fine. Okay, and commutative for multiplication, same thing, AB equals BA. Again, that's just saying the order you add in doesn't matter, and the order you multiply in also doesn't matter. You can flip those around. Okay. All right, so that's everything for today. I know that this was a little complicated. This is not on your quizzes, okay? 4.1 properties, these ones are on your quiz. Everything from 4.4 is me making sure that I have shown you technical math language of how we actually do this, so that you have seen it as you go forward in math. I do not expect you to memorize these, okay? You do need to memorize 4.1 stuff, but this stuff is just making sure that you have seen it. So don't stress too much about it. The only thing you have to do on your homework is say, like, oh, I added 5. That's the additive property of equality. Okay, so don't stress too much, but I did want to make sure that you have seen the technical math language. That's my job. So if you have any questions, let me know.